All right, let's talk about a word that, let's be honest, can make a lot of people a little nervous. Trigonometry. It just sounds so complicated, so abstract. But what if I told you it's actually a really simple, powerful, and kind of beautiful way to measure the world all around us? Well, in the next few minutes, we're going to pull back the curtain and demystify it completely. Sound familiar? Yeah, we've all been there, staring at a math problem, thinking this exact same thing. And you know what? It's a totally fair question. So today, we're not just going to answer it. We're going to take apart the mystery so you can see for yourself why this stuff is actually pretty cool.
So, first things first, let's just break the word down. It's not some scary, made-up term. It actually comes from two simple Greek words, trigonon, which just means triangle, and metron, which means measurement. That's it. Seriously, trigonometry is quite literally the science of measuring triangles. Nothing more, nothing less.
Okay, so to measure a triangle, we've got to understand its parts first. And for this, we're going to focus on the real star of the show, the right-angled triangle. Now, it has three sides, of course, but how we label them, well, that is the absolute key to unlocking everything else.
In any right-angled triangle, you have one side that's your rock, your anchor. It never changes. No matter how you flip or spin that triangle, the longest side, the one directly across from that little 90-degree square, is always called the hypotenuse. That's the one constant you can count on.
But here's where the fun really starts. The names of the other two sides, they actually depend on your point of view. So let's say we're standing at angle A, down in the bottom corner. The side that's right next to us, touching our angle, we call that the adjacent side, or the base. And the side that's way over on the other side of the triangle, across from us, that's the opposite side, or the perpendicular. Now pay close attention, because this is probably the most crucial idea in all of basic trigonometry. If we walk over and change our perspective to the other angle, angle B, the labels completely swap. What was the opposite side is now right next to us, so it becomes the adjacent. And what was adjacent is now all the way across the triangle, so it becomes the opposite. The hypotenuse stays put, but the other two are totally relative. It's all about where you're looking from. Okay, so now that we know how to name the sides from any angle, we can start to see how they relate to each other. And this, right here, is the real heart of trigonometry. It's not about memorizing a bunch of crazy formulas, it's about simple comparisons or ratios. I like to think of them as just nicknames for how the sides size up against each other. So let's think about this. A triangle has three sides, right? If we want to compare them two at a time by making a fraction, a ratio, how many different unique combinations can we actually make? Just 6. That's it. Not 100, not an infinite list of formulas to memorize. The entire foundation of trigonometry is built on just these 6 possible comparisons. See? Suddenly it feels a lot more manageable, doesn't it? And here they are. These are our 6 nicknames. All we've done is give a special name to each of those 6 comparisons. So the ratio of the opposite side to the hypotenuse, we just call that sine. The ratio of the adjacent side to the hypotenuse, that's our old friend cosine. And opposite over adjacent, that's tangent. The other 3, cosecant, secant, and cotangent, they're just the flipped, reciprocal versions of these first 3. Easy peasy. All right, so we've got our building blocks. We know the sides. We know their 6 ratio nicknames. Now let's put these tools to work and see how they all fit together to solve actual puzzles, like finding missing pieces of a triangle. And here's where we bring in a familiar face, Pythagoras' theorem. This thing is basically trigonometry's best friend. You probably remember it. A squared plus b squared equals z squared. It tells us that if you know any 2 sides of a right-angled triangle, you can always find the third. And this is where it gets really powerful, because if you know just one of those 6 trig ratios, you can use it with Pythagoras to figure out the lengths of all 3 sides. Let's walk through a quick example to see how this works. Say someone tells you that the sine of an angle is 3/5. Step 1, just draw it out. We know sine is the ratio of opposite to hypotenuse, so we sketch a triangle, label the opposite side 3, and the hypotenuse 5. Step 2, find the missing side. We bring in our best friend, Pythagoras, to find that adjacent side, and it turns out to be 4. And boom, step 3, we now know all 3 sides are 3, 4, and 5. From here, writing out the other 5 ratios is a piece of cake. Just knowing that one single ratio unlocked the entire puzzle. Okay, so what about specific angles, like 30 degrees, 45 degrees, or 60 degrees? You've probably seen those giant, scary-looking tables of values that seem like something you just have to painfully memorize. Well, forget memorization. It's all about seeing a simple, beautiful pattern hiding in plain sight. Believe it or not, This one single row of values for sine is all you really need to know. That's it. Just look at it. It follows this nice, simple progression starting at 0 and climbing up to 1. If you can just get this one simple pattern down, you're pretty much set. So, how do we get the values for cosine? Do we need to learn a whole new set of numbers? Nope. You just take that sine row we just learned and you write it backwards. That's the entire trick. The value for cosine of 0 is the same as sine of 90, cosine of 30 is the same as sine of 60, and right on down the line. It's that simple. And to finish it off, what about tangent? Well, the pattern just keeps going. You simply divide the sine value by the cosine value for each angle. So for 30 degrees, you take 1/2 and divide it by √3/2, which simplifies down to 1 over √3. The entire table is built from just one simple row and two super simple rules. No heavy memorization needed at all. So let's just recap the big aha moments here. Trigonometry isn't some monster under the bed. It's just the language of triangles. We figured out that side names, like base and perpendicular, totally depend on your perspective. There are only 6 simple ratios to worry about. Pythagoras is your go-to partner for solving problems. And even those big tables of values are built on easy-to-remember patterns, not rote memorization. Now that you understand this basic language, you've really unlocked a brand new way of seeing the world. The angle of a ladder leaning against a wall, the shadow a tree casts on the ground, the hidden structure of a giant bridge, they're all just puzzles made of triangles. So the only question left is, now that you speak the language, how many can you spot?